Hey guys, hope you're doing well today. Gonna do another video for you. New chapter here. I'm sure some of you guys are glad to be out of that similar figure business. This is something that you guys will be much more familiar with, and I hope you can get better at. So here we go on chapter 8, section 1, the Pythagorean Theorem, and we're gonna learn about some special right triangles as well. Alright, so you guys know the Pythagorean theorem. A squared plus b squared equals c squared. Discovered by this ancient Greek society known as the Pythagoreans. Okay, Pythagoras was their leader. He might have not came up with this theorem. That's a mystery. And that group worshipped math because it was, the thing to do back then before, Jesus came around. So, anyhow. So this theorem basically allows you to figure out any side of a right triangle when you know the other two. All right. It doesn't matter which one is A and which one is B as long as you don't make A and B C. C is always the hypotenuse, which is the longest side, okay? And it's always the one that's right across from the right angle, okay? So C is always the hypotenuse. So make sure the longest side is the one that's by itself. Okay, so the hypotenuse needs to be by itself. Now, this theorem, really what it's saying, okay, and why it works here, this is a little geometric proof of it, okay? So if you were to take one side of the triangle and figure out its area by taking, let's say, A times A to get the area of the side that is A, that would have area A squared. And then you would take the other side and figure out its area, which is b squared. All right, if you combine these two areas, okay, so this one has, in this picture, this has area 9, and this one has area 16. Okay, so there's 9 little squares and there's 16 little squares. Well, the third side, okay, the longest one will have that same area if you add the blue and the green squares together, you get the area of the red square, okay? And that's true for any triangle that's a right triangle that you draw, okay? The areas of the two smaller sides, when you figure out their areas, added together is equal to the area of the larger side. So it's based off of area, this theorem, okay? There's also a converse to this theorem, okay? And that is if you have numbers that plug into this formula, okay, and it's a true statement, those things, those three different numbers would form a right triangle, okay, provided that you make the longest one C, okay, the hypotenuse. So if this, so basically the three numbers that make this true means that you have a right triangle. You can read it there if you want. All right. Next, we're going to do a couple examples of this, and you guys probably know how to do this already, but that's okay. You might struggle with the simplifying. We're going to go with precise answers, not decimal approximations here. So that means you have to simplify the radical. All right, so we're finding AB. All right, now is AB the hypotenuse or a leg? AB here is the hypotenuse, okay? So we are finding C. So AB is essentially C, okay? So you want to make sure to always figure out which one is C, okay? Which one's the hypotenuse. So since we're doing A squared plus B squared equals C squared, and we know A and B, we would do 12 squared plus 15 squared, okay, equals C, okay, C squared. So I'm going to put AB, okay, to represent that side length, and AB squared. Now, if you don't like doing that, maybe you might get confused. You got too many A's and B's going on. You could write it like this. Of course, this would actually be squared, okay? But for simplicity, what we could do is erase this here. If I could figure out which one's the eraser. All right, we got the eraser there. We could just call this C squared. All right. So it's good to have a calculator here, of course. 15 squared, some of you guys, most of you probably don't know that. That's 225. Okay? And that's equal to c squared. If you add up 144 and 225, you're going to get little sound effects. All right, 369. All right. Now your answer is not 369. That would be like one ginormous side length, given the other two is that. All right. What we need to do is simplify. Now, before we try simplifying, I mean, we can't really simplify it until you realize, hey, I got to take the square root of both sides to find my answer, okay? So the square root of 369 is what we are going to simplify. Square root of 369. All right, so what you need to do is think about your perfect squares and figure out, like I would start with maybe the largest one you guys know, which is 12 squared, which is 144. Then you have 11 squared, which is 121. Then you have 100, which is 10 squared. Okay, start with the largest one and work your way downwards to see if it goes into 369. All right, now the one that actually goes into 369 is gonna be, let's see. Well, I'm trying to figure it out here myself. Well, we might have to keep on going down a little bit more. Okay, so you might, now 81 doesn't divide into it. 64 doesn't divide into it. Okay, so I'm taking 369, I'm trying to divide by 64. No go. 369 divided by 49. So you want to keep on going down your perfect square list. And by the way, we're at 7 squared in case you weren't following along. 36 would be the next one down. 25, 16, 9, 4. Okay, so you could keep on going down to 1, but there's no point in putting 1 down. So the one that actually works is 9. Okay, you can split up square root of 369 into the square root of 9 times the square root of 41. Okay, so that's a little bit harder than what we were doing with decimal approximations, but you're just using your perfect squares to simplify this so you're getting a better exact answer out here. All right, square root of 9 is equal to 3. So as soon as you take that square root and you actually do it, it's going to leave this square root, which is also called the radical symbol. So you're losing the radical, okay? The radical goes bye-bye. All right. Sorry, I got a little carried away there. 3 times the square root of 41 is equal to c, okay? So the square root of 41 doesn't lose the radical. It's stuck underneath the square root. The square root of 9 does because it's a perfect square. So you always want to try to simplify the radical. You want to split it up into one of these, okay, which are perfect. These are perfect squares because you can actually take the square root of them. Perfect squares, unlike that one right there. All right. So I want you guys to try to figure out this one here. All right. And you can pause the video and figure it out. All right. So in this one, we're finding EF. Now, is EF the hypotenuse? Nope, it is just the side. So if it's just the side, I most of the time just label it A, okay? So we're trying to find out EF. So it would be A squared plus 7 squared equals 10 squared. Okay. This one's a little bit different because you aren't finding the hypotenuse. Okay, 7 squared is equal to 49. 10 squared is 10 times 10. Okay, remember 7 squared is 7 times 7, not 7 plus 7. Okay, that's a common mistake. So that's 100. Now you need to get rid of the 49, so you're going to subtract it. Subtract 49 from 100. You're going to get 51. All right. And then your last step is to square root both sides and try to simplify the square root of 51. And you go down through your list, try for 25, 16, 9, 4. None of them work. All right, so that's your answer then. So EF is equal to the square root of 51. Isn't that cool? All right, let's go to the next one here. All right, so in this problem, the length of each crosspiece of the fence is 10 feet. Why would the rancher build with these measurements? Okay, so they're saying that the cross piece here is 10 feet. Well, the reason why they would build with these measurements is because 6 squared plus 8 squared equals 10 squared, which means that would form a right triangle, which would mean that this piece here would be perpendicular to the ground, okay? Which stabilizes the fence, basically what I just said there. Because it satisfies the Pythagorean equation here, we know that we have a right triangle and it's nice and stable. These three numbers here, and any three numbers that satisfy this equation, are called Pythagorean triples. And they're special kind of neat numbers that make right triangles. And here are some common Pythagorean triples. The one that you actually saw is a doubling of the very basic one that is easy to remember, the 3, 4, 5 triple. Okay, so if you double each one of double 3, double 4, double 5, you get 6, 8, 10. And you can triple the triple, okay, and you get 9, 12, 15. And these are all different common Pythagorean triples that would actually work in the equation. All right. Here's a couple more examples using the Pythagorean theorem. So I want you guys to go ahead and try them and see if you get them right here. Then I'll explain them. All right. So in this one, are we finding a leg or hypotenuse? This is the hypotenuse. So we're finding the hypotenuse. Okay, so you're going to do 9 squared plus 40 squared equals c squared. All right, 9 squared is 9 times 9, which is 81. 40 squared is 40 times 40. 4 times 4 is 16. And then you have 2 extra zeros, so that's 1600 equals c squared. All right, so you have 1681. Now, before you try to simplify this, okay, and splitting it up, and when I say split it up, I mean use these numbers and divide into it and try to simplify that. You should always check to see if this number itself is a square root. All right, so what is the square root of 1681? Let's see if you did that right. Oh, is it 41? Well, let's see, 1681. I'm just taking a guess there. Oh, it is 41. All right, yep. So I just want to double check myself, make sure I got it right. So C is equal to 41, which is KL. It's good to label your answers clearly, okay? All right, and the next one, is it a right triangle? And to decide if it's a right triangle or not, you have to make sure to use the Pythagorean theorem. Okay, the hypotenuse needs to be the longest one, so that needs to be C. A squared and B squared doesn't really matter. It's the other two. Okay, so is 12 squared plus 35 squared equal to 37 squared? And the answer is yes. Boom. There is all the work for it there. You get 144 plus 1,225, which adds up to 1369. So they're both, and 37 squared is also 1369. So it is a right triangle. We call these numbers 12, 35, and 37 a Pythagorean triple, meaning it satisfies a squared plus b squared equals c squared. All right, real quick, we're going to do one more that might be a little bit more challenging here. We are trying to find RS. Okay, so is RS A, B, or C? Well, it's either A or B, okay, because we know the hypotenuse is TS. So let's go ahead and call RS A. So we have A squared plus 9 squared equals, all right, so we have 5 times the square root of 10, and this is squared. Now that's a little bit tricky, okay, so my A and my 9 look kind of similar, all right, so I apologize for that. So A squared plus 81 is equal to, now when you square this, you have to square the 5, which is 25, okay, and the square root of 10 squared is just actually equal to 10. All right. When you square a square root, it cancels the square root out. So you have a squared plus 81 equals to 250. Okay. And subtract 81 from both sides, you get 169. Then you square root both sides and you get 13. Kind of had to sum that up there real quick. All right, guys. Have a great day. See you tomorrow. Bye-bye.